Good morning, everyone. My name is Surinder. My roll number is 20951 A0231. My branch is Dribbling. My subject is electrical measurement and instrumentation. We are talking about the tech talk presentation. My topic is power measurement using the Valatent transform. What is a power measurement Valatent transform? This paper provides the theoretical base for the demonstrate the practical applications of power and energy and RMS measurement directly for the wavelet transform data associated with each voltage current element pair. The advantage of using the wavelet transformer data directly is that is provide the distribution of the power and energy with respect the individual frequency bonds associated with each level of wavelet analysis frequency level of levels is achieved using IIR filters because their magnitude characteristics are much better than typical fire filters of equivalent complexity. Of the IIR polyphase network strategy yield a simple wavelet filter bank design. Introduction. The the increased utilization of nonlinear power electronics coupled with the more microprocessor based equipments has brought power quality issue on the distribution network to the forefront. In this environment, power quality analysis strategies have usually been divided into those which address steady state corners, such as a harmonic distortion or voltage imbalance, and transient corner, like those resolutions from the fault or switching transient techniques such as a Fourier spectral analysis or symmetrical components are often applied to the former class for problems, while wavelets, classical transistence analysis, and computer modeling are traditionally used for the latter. This, this study provides the basics for the using of the wavelet transformer for the power and energy and RMS both transients and steady state situations and demonstrates the application to both simulated and actual power system waveforms. The wavelet transforms has been has proven a powerful signal processing tool in the communication in such areas as data comparison, denoising, reconstruction of the high resolution image, and high quality speech in the power system areas. It has been quite successful in identifying various categories of power system disturbance. Analysis as usually focuses on individual signal. However, in the case of power measurement, the voltage and current wavelet transforms are derived from the sequence of concurrent samples using a common orthonormal valet base applied over each power system cycle. Since the individual subbands for the voltage and current are registered in the both time and the frequency, each associated product subband represents the contribution this band to total element average power of or cycle energy. The summation of these signed subband powers then result in the total average power for this element pair. Power would normally be used under steady state conditions. Those areas, the energy frequency distribution would be of importance under transient. In a similar manner, the square of the points in the individual voltage and the current subbands represent the squared contributions of the individual subbands to total RMS voltage or current. That is because the subband contribution are orthogonal, the mean squared the contribution of each subband can be added to from the mean square of the total voltage or current. The square roots of the sub will yield the total RMS values, while the square roots of the each subband's means square will yield the respective contribution of the subband to these total RMS values. In the three-phase power system, the power or energy, the contribution of each phase or elements in the case of three-wire or two-element metering can be summed by each subband level to determine the contribution of the frequencies within this subband three-phase total power energy. For the accurate analysis power of system data, good frequency separation is required among the decomposed the various of other original or roll off the characteristics of the high pass and low pass filters. Pairs are using developing the wavelet transform strongly influence the accuracy of the resulting subband frequency distributions. Frequency separation into the various wavelet level in the achieve using a IIR filters because their magnitude characteristics are much better than the typical fair filters of equivalent complexity. The IIR, the polyphase network, strongly yield a simpler wavelet filter bank design. Wavelength theory. The derivative of in the classic work provides the foundation for the wavelet transform and it is origin in the multi-resolution. It's shown that the orthogonal valet basic formed from the multi-resolution property. Multi-resolution analysis and orthogonal basic. Multi-resolution analysis provides a natural framework for the understanding a wavelet basis and contribution of the wavelet transform. Multi-resolution analysis consisting of sequence of successive approximation space and has following properties. You can see the multi-resolution properties. Can be working on this level 1 and level 2. Evaluation. The evaluation examines two test two test sets. The first one is derived from the analytic signals, and the second is data acquired from the bus and industrial power system. These power measurements are performed on the RMS and the power of simulated signal and cycle of design under steady state condition. Six level of the wavelet transformer result from 128 points for 60 kilohertz. Fundamental cycle was derived from the simulated signal. The wavelet level with the associated numbers of the coefficients, the frequency bands and the odd harmonics which are the included in these frequency bands. Level is scaling level and the reset the wavelet levels. You can see the table 1 and table 2. The number coefficients and the frequency bands, and second table is RMS and power test first and fifth. Analyzing the industrial power system data. The current and voltage pair represent the cycles of the phase A data from the actual three-phase power distribution. The wavelet coefficient drops the result from the using the two-channel IR polyphase for the filtering same. Conclusion. The power and RMS measurements are performed with two sets of periodic data using proposed the valid based on algorithms. First, the simulated data, and second, the actual phase voltage. The current of the data from the power system. Steady state and using the evaluation so the individual subbands power could be compared with the Fourier transform. The simulated data enters the table 1 and truth, and the derived the analytical function using the generate the transient point data and agree the preset head and cited. This test is demonstrated both. Thank you everyone.